Yeah, so in this video, you'll be making this jumping character that's right on screen now. You'll also have animations for the character that you can use later in your game for like walking, jumping, and not attack animations. I'll deal with that in a separate video. But today, I'm gonna teach you BlockBench and Godot 4 with this. Let's get right in. Hey guys, welcome to this video. Today we will make a 3D model in BlockBench and animate it and export it and make it work inside of Godot. We're going to be doing this with the help of this application called BlockBench, and we're going to bring it into Godot as this thing called a GLTF, which Godot natively supports. And of course, you don't need an FBX exporter or importer for that. It's a very complex thing to bring FBX files into Godot, so it's a good thing to use GLTFs, right? Okay, so if you do not have the latest version of BlockBench or the latest version of Godot, you can go ahead and check the links in the description. I have provided the links to both. Okay, now let's start creating the model. We're creating a generic model as it's the most suitable for game engines and rendering. Now, we'll name the file block because he's just going to be a normal blob who's like your friendly neighborhood blob or something. He's not exactly a blob, he's more of a blocky guy, so he's a block. Now, under the outliner, you can add a cube or add a group or so on and so forth. First, a group is essentially a bone. See, you have this pivot point here, right? Around this pivot point, stuff rotates when you rotate it. That's how a bone works in BlockBench. Now, we have this thing called a body bone now. Okay, under the body bone, we want to have a head and arms bone. And under the head and arms bone, we want to give ourselves a head bone and an arms bone, obviously. Bone. I made sure to let you guys know of the hotkeys because you need to like learn them. So it's on the bottom right corner of the screen right now so that you can check them out. Okay. Now the head and arms are here. Now what do we need? We need legs. And for legs, we need to create a group called legs. How many legs does a normal person have who's not paralyzed? He has 2 legs. One left leg and another right leg. Another right leg. Right leg. Voila. And now let's go on the head and arms and let's add, no, not a head bone. Now you can add a group. Let's call it and left arm it is, and then under that let's add a new group, right arm or R arm. No, R arm. Yeah, RARM. Yeah, we have the head, we have the arms, and we have the legs, but we have nothing on the screen. That's the problem, right? So in BlockBench, these bones, these are essentially folders with pivot points around which the cube will rotate. You can either have a cube or a mesh. I'll show you how both work. Now, let me just add a mesh. This is going to be a cuboidal mesh that you can edit. See, you can increase the diameter to make it bigger or decrease the diameter to make it smaller. I'm going into project properties and I want to set it to 32x32 because that's how I usually make pixel art. And yeah, that was how you add a cuboid. There are plenty of other shapes here too. You can choose a torus, which is a donut, or a sphere, or a cone, tube, cylinder, any one out of those things. Okay, now that we actually have bones, let's add some cubes to those bones. As I said earlier, you can also use a mesh, but cubes are the most simple to control inside of BlockBench. so I'm using that. Okay, we want an 8 cube. We want 8 cube sized thingy. Let's center it. Let's lock onto the y-axis and center it. Now I'm going to give you a very important tip. When you're modeling, you're always supposed to model facing north, because north is forward in most game engines, and we don't want our game to be incompatible with a lot of game engines. And now this is the head cube. Let's go to arms. Let's add a left arm and a right arm. Okay, let's add a cube under that. Bring the cube towards the left. And let's add a height. Somewhat of a height like that. Yeah, I think that'll do. Now, let's duplicate this. Okay, now we're going to check what cube goes where. Remember, model facing north. This is not the left arm. So this cube, it needs to leave to this side. Let's check if the units are correct here. Of course they are correct here. Yeah. We have the left arm and the right arm now, and the arms, their structure is completed. And now we can, bring the head and arms up. Let's look at them from this angle. Are we satisfied? Like really? No, I'm not satisfied at least. Yeah, I think that looks okay. And now let's add 2 legs. For legs, I'm just gonna be adding 2 blocks. That's it. 2 literal blocks. Those are legs. In my case, at the very least. We've always got a model facing north, so let's face north again. Yeah. Under the left leg, we add a cube. And we're just going to extend it forward, so we adjust the Z axis. Because Z is forward, remember? And since we have to model based on north, this is how stuff looks. Okay, let me fix that. This is too forward. Yeah, this looks correct and perfect. Now, all we've got to do is duplicate this and put it there, and then edit it in such a way that it works properly. I believe this is a better configuration for the legs. Or I think this is better. Yeah, this is objectively not better. This looks better to me. Okay, now we have our blocky guy. Now what? Now what do we do? Well, that's simple. We add a texture to him so that we can paint over him. But before we do any of that, how am I just dragging and it goes up? If you're not familiar with the coordinate axis, then think about it like this. When I say y-axis, it's how tall something is. It's more taller, the taller I make the y-axis, and it becomes shorter as I decrease the y-axis, the position of this point here, right? It drags down stuff, or it makes stuff go up. That's simply it. One arm is bigger than the other now. I have to fix that. Yeah, voila, now we're done. Now that we've finished modeling, it's time we add a texture to it so that we can paint on it. Now we have this element, UV and everything else here, right? When we switch over to paint, you'll see this textures option. So now I want you to select one thing, go over to textures and add or create a texture actually. Use padding. Padding essentially means that there's a small padding or a gap between individual parts of your texture, so that if you make a mistake, it's easier to rectify in this thing called a UV. A UV is essentially the 3D model's texture It's like you're unwrapping the whole cube right now and you're placing it on a singular surface. I'll show you how it looks, don't worry. We're going to call this texture head because it's the texture of the head. Okay, now let's repeat for the same again and again. It's a 32x. Now this is the left arm's texture. This will be our left arm, and we're gonna switch on padding. Again, we're gonna do the same thing for the right arm. We're going to create a texture, and it's going to be the right arm's texture. And we're going to turn on padding, and we're going to confirm our operation. We're going to do the same thing for the right leg. Right leg. Padding is confirmed, and then we have the left leg. After this, we can start painting. Voila, we're nearly done. Left leg. I've made the left leg right now, and I've turned on padding so that there's a gap in the UV. Okay, now we really don't need to worry about UVs because we can paint directly on our models. In BlockBench, we have this paint bucket tool that allows us to fill faces or elements or connected colors or just colors. If I used colors, it would only fill in this part, the colors that are like just that. And if I said connected colors, it does the same thing, but if there's like a gap between two colors in the same thing, it will just ignore that. It's harder to explain than to say. I'll just show that to you right now. Okay, now we're back in paint mode. Now we're going to switch from that to this element. This colors the entire element. Okay, now that if you really think about it, like really carefully, you'll notice that there are load, save, and sort palette options, or generate palette options, or export palette, or import palette. The default options you get are the Ensega 64 and default and material. Material means whatever material you have in here, it will unwrap that into its different color components. So if you want a new palette, then go to import palette and you can see stuff from your file manager. Yep. You can see stuff from your file manager. I don't really need that right now. So I'm going to go ahead with the existing Ensega 64. I want a red color for the character. You can just like touch the stuff you want to get filled and they'll get filled. Okay, what about eyes? Well, we'll add eyes right now. No. It really shouldn't work that way. Let's go from the paint tool to draw shape tool. First, let me like fix this mess I've created here. And then let's go there. Now we're going to draw eyes, which are basically squares for our character. And by the way, I'm drawing with a mouse. So if you think you have something else, like a graphic tablet, it would be a good thing to use it. I also have a graphic tablet, but I'm just using a mouse for this one. Okay, now this looks like a very small character that could be used in a game as an NPC or something, but believe it or not, he's gonna be our main character. Let's like add a side eyebrow to him and another side eyebrow to him. They need to be symmetric, right? So CTRL-Z means undo. Okay, it's 3 units. 1, 2, and 3. Voila, we're done. We're done painting our model. Now let's go to the animate tab so that we can animate stuff. We're going to make the timeline shorter so that we can actually see our model while animating. Okay, now here's our model. Now, what do we do with him? Well, To animate, we need an actual animation. Let's put this to the right sidebar so that we can control it easier. Okay, what's the new animation going to be called? It's going to be called the walk animation. We're going to be animating the walk cycle, and I'm going to teach you how different parts of keyframing and animation works on this one. It's going to be a looping animation because when we're walking, we're essentially doing one step, another step, and another step after that, and so on and so forth. Now, we want the head and arms and the left leg and right leg for animation. So we select them in the outliner. Now, what do we do? Well, the first thing is we add a keyframe to the rotation. What do keyframes mean? Well, a keyframe indicates that, hey, in this frame, I want this thing here. So I'm going to say, I want the rotation of the right leg to start from like behind. But to make this work, we have to adjust the pivot. So let's adjust the pivot point above. I think 8 works. 8 works, doesn't it? Doesn't 8 work? Eight does work. Now I'm at the right leg, so I've got to push it rightward. Yep, now that will work. And now 8 again. And then this time we're gonna push it leftward. Yeah, now things should work as intended. What is a pivot point? Well, if you really think about it, a pivot is like a hinge joint on a door. If you move stuff around a hinge, like if you open a door, it opens around the hinge, right? So it's the same thing for a pivot. But you can do that with 360 degrees. A hinge just allows one directional motion, doesn't it? Now, first, let me alternate the legs' positions. How do we do that? We're going to rotate one leg backward and one leg forward. In my case, I'm going to start with the right leg going backward 45 degrees. 45 degrees just means that we're turning things backward around that pivot 45 degrees. The whole circle is 360 degrees and I want it to go 45 times behind. So I'm saying 45 degrees. And well, forward implies minus 45 degrees. It must really not be intuitive to you, right? It's not that hard, but it's not intuitive, that's all. Now we're going to add a secondary keyframe. At the end of our animation, we'd like our leg to come back to the spot it originally started moving in. We want to say a rotation keyframe comes here, and then we alternate the positions at the center. Okay, so to do this, we add a keyframe. We're going to take the minus off the left leg so that it gets back, and we're going to add the minus to the right leg, which will make it go forward. We're going to add the 2 keyframes to the right leg as well, and now this 45 becomes minus 45. Now we're going to see the legs alternating between different positions, and that's totally normal. But hey, if you really think about it, doesn't this really feel robotic? I really don't want a robotic movement. So we're going to adjust the interpolation. What is interpolation? Well, going from this keyframe to this keyframe, it maintains a constant speed, like a block per second or something, right? Interpolation is essentially that. Bezier means that it's not maintaining a block per second. It slows down at the starting and it speeds up as it goes on and it reaches the final point. That's what Bezier does. So we're going to add Beziers to the 3 different keyframes that we've created. Okay, that's so cool. It works now, doesn't it? Now, let's move to the head and arms part. Why did we put the head and arms under the same part? Well, it's to create idle animations. Idle animations are essentially the body going up and down and shaking as the player moves. It gives you a sense of life when you look at your player moving that way. So that's all there is to it. We're going to add 2 position keyframes, and we're going to add a position keyframe at the center, which will mark a dip in the position, approximately 2 blocks. Okay, we have a Bezier motion here, and we're going to add another Bezier motion here, and we're going to add another Bezier motion here. Smooth is essentially a Bezier, but it only happens when stuff starts or ends based on the keyframe you're using it for. Okay, now the character is walking very lively. Let's look at him. I know that kind of looks weird that the head and arms are in like perfect coordination, but this looks at least a bit acceptable for a game, right? Yeah, I think it does. So now, let's go ahead and add the left walk, right walk animations, and let's also add a backwards walk animation. Okay, I'm going to power through this one. Since I already taught you the walk animation, you can go ahead and experiment with different things to create a jump animation. We're going to have to create a back walk animation and these things. But first, let's start with a jump launch animation. This only plays once the player clicks the jump button. So it's going to be a play once type animation. Remember that, it's very important. Okay, in a jump, the player moves up and down, right? So do you really move the player up and down? No, you don't. That's the tricky part. Well, it's because when you press jump, the entire body of the player is lifted up by the game engine itself. So you don't have to animate that here. So you only have to animate the effect of that happening, which is essentially the head being squished down by gravity, as the legs are very much lightweight and they can hold up in space. For our character. Yeah, that's right, I forgot to say that. Okay, now this animation will take place over the course of 0.5 seconds. Our player's head gets squished down as he launches himself into the air. It's -4 units, I have to note that. Yeah. This is the jump launch animation. It doesn't look very lively, right? It's gonna look like that. Now what we've got to do is we've got to edit some properties here. Hold on to last frame. No, I don't think we need to do that, because I want like a static single frame animation that can play throughout the course of the jump. Now this will happen when the player is in air, which is essentially the head going down 4 units. The position, we're only going to have 1 keyframe here, and it's going to hold on to the last keyframe. Okay. Now we're going to make it -4 units. We're done. We're done for the in-air animation and the jump animation. This will keep playing as long as the player is in the air, and jump launch happens whenever the player is launching himself from the ground to the air. So I think Bezier would be a better choice, but I think it's just my head speaking. No, smooth is a better option here. Smooth essentially means that at the last moment it will slow it down. It won't slow down at the beginning. That's what we need. It's gravity, buddy. He's like a spring. He's like going in and he stops. Yup. That's done. We literally have it done. We have the jump animation, jump launch, and an in-air animation. And we just want a landing sequence right now. Like when the player is like falling down and the velocity is in negative integers, or how many blocks he's falling per second, that's negative, which means he's coming down to the floor. Now, I'll add this animation. What do I call it? This is gotta become, okay, what the hell is wrong with this keyframe thing now? Oh no, I really don't want this to happen. Okay, let me like go back to edit and get back to animate right now. Oh no. Now the in-air animation is here. We've got to make a new animation called the fall animation. This is also going to be a static state when the player is falling down. His body's going to get stretched out quite a bit, right? And he's going to get stretched whenever he's like falling down. So we have to initialize that. It's not essentially a static animation. It just holds him to the last frame. Fall, we're going to call this fall start. Fall start. He's going to start falling. Now, what do we do? It's really a huge question, right? Well, we have two keyframes. We could make a keyframe like, bring him back up to his normal position, and we won't even need a normal, fall land animation. But I'm choosing to do something else right now. Oh my, there's some really weird glitch here. So I'm gonna bring this to the left sidebar so that I can at least control it that. The y becomes -4. Remember, we did this before in air. So it starts there and it elongates his body back to his normal position as he falls down. And this, my friends, is going to be the next animation. Up, and yeah, pretty much that's it. -4 to 0. We're going to interpolate between them in a Bezier fashion, which means it's going to start slow because like the spring needs to gain acceleration, and it'll stop due to the gravity pushing it down. Sorry for speaking too much physics here, but I can't help it, sorry. And now the fall start is here, and we're going to need a normal fall animation, which is essentially no animation at all. It's just gonna be the fall animation. It's just gonna be the fall. Hold on last frame, and we're going to have one frame here, and that is it. We have everything done. We have a fall animation, fall start animation, an air animation, and yeah, that's pretty much it. Our player doesn't like bounce on the floor when he like lands. Let's assume his feet are steady enough to hold the impact head on. Yeah, that's pretty much it. We have the model ready. Let's look at our animations first. He runs like that, and then he jumps or launches himself into the air, and then this has gotta become, hold on to last frame. And now we're going to add another animation, which is going to be his idling state. Like, what does he do when he doesn't do anything? That's the idle state. Okay, now let's add the thing in this manner. Position, we have like 3 alternating keyframes, whereas head and arms go up and down like an endless loop. It like goes that down. No, we don't want that. So what we do want here is essentially him doing this and going back up, and we don't want that to be too bad, right? So it's gonna stay here. So he's gonna go a block down and get back up, a block down, he's gonna get back up. So this is gonna be a Bezier interpolation. So this is how it's gonna look. This is a looping animation. Oh, I forgot to change the loop mode, did I? This seems too fast, right? Well, I think so too. So let's put this to 0.75 and let's drag and drop it to the center part. So it becomes like this. It's a bit slow now, but it could use some help. So let's bring it to 1 and let's bring this to 0.5. And yeah, that seems like he's breathing after a heavy run, which is exactly what we need. We're going to add a smooth here and a smooth there. It's like he's breathing really badly. Like you can vibe with his breath. Yeah, now that we have a walk animation, jump, launch, in air, fall, start, fall animation, we can go ahead and make left walking and right walking animations too. Left walk. Why are we naming our animations precisely? Because we're going to access the animations by their names in the future. So we need like good precise names to indicate what is what to us. So we need to order stuff up, that's it. Now, what we've got to do in the left walk animation is essentially, you know, the left leg and right leg, right? We've got to like rotate them sideways. Like one leg goes that way, the other leg goes that way. It's alternating in that fashion again too. So the rotation will be the first keyframe, and I'm going to rotate keyframe that. It's gonna be this is the left walk animation, right? So I have to animate. Oh, this would have become a right walk animation. What the hell was it thinking? Now I've got to delete this keyframe and I've got to add a new keyframe. Now, for starters, no, not that direction. Yeah, 0. 0 that up. Now 45 degrees. Minus 45 in the Z axis. And the second would be at 0.25 seconds, I presume. This would be a third keyframe. He's walking sideways, right? Now he's got to get back to the center. 0. Yup. That looks really weird, but I think we could make do with that. Let's loop it a bit. Okay, that is very weird. Let's at least add it to 0.75 and check if this gap is enough for it. The spacing looks okay now, so let's add a Bezier interpolation at the end and smooth interpolations at the beginning to make stuff look better. Ah, it looks really good now, doesn't it? So why aren't we animating the body moving towards the left? That'll be taken care of by our game engine of choice. So what we've got to do right now is create a right walk animation. Yeah, this is gonna be a right walk animation. That's pretty much it, right walk. And here we're going to add a keyframe to the first rotation of our left leg, no, our right leg actually. Left leg doesn't get a keyframe. I think it can have a keyframe. Nothing's gonna change. So let's get to the middle keyframe, which is 0.675, I presume. And then let's have the end keyframe, which is at 0.75. No, let's just first have one keyframe and have it be duplicated. Okay, 45 degrees towards the right. And 45 degrees again. 45. Yeah, we're done. This is gonna be the center. So we're gonna add a keyframe here. And this is, no, not that. Yeah, this gotta become 0. Enter. No. Yes. Now let's add a Bezier interpolation there and a smooth linear interpolation there. No, a smooth interpolation there and a smooth interpolation there. Stuff is gonna look really cool now. See? So now it's not a play once. I want to like loop. So that's the right walk and that's the left walk, and now we want a backwards walk. So we take this, we're gonna duplicate that, and we're gonna rename it to B walk. Forward walk is just normal walking, so I'm gonna leave it at that. Or should I like label it? Yeah, I should label it F walk. Okay, now we have most of the things set up for our forward walk animation. Let's play it and see. What should we change here? In my opinion, we don't really need to change anything, but if we did want a small difference from that, we could like rotate the entire character's body, which I'm not going to do. You can add a keyframe here and then set X to Y to 180 and it'll make it walk backwards. This is fine for me, so I'm going to save this model as is. Blocky. I'm gonna call him Blocky BB model. No, I wanted a 3232 texture size though. Confirm that. Yep. Yeah, the texture thing has changed. Now we have Blocky ready for us. He's gonna have all the animations. All we've got to do right now is just go into Godot. Let's go into Godot. Yep, now we've got to create a new project. It's really rainy behind me, don't mind the noise. All we've got to do right now is create a new project in Godot. I'm going to create a new project called Projoid and create folder and create an edit. Don't really criticize me on this one. This is just a tutorial video. I'm not creating a professional game, so I don't have to think about the name that much. Now the Godot engine is booting up our project. We've gotta wait for a bit. Windows updates really slow my PC down sometimes, so this was one of those times, I guess. We're going to create a node right now. We're gonna do modular programming. What does modular programming even mean? It sounds so weird, right? Well, modular programming is essentially this idea that you use everything in modules. So the stats node here, right? It essentially stores our stats, so that we never have to write the variables by hand ever again. Okay, how do we make use of this? Well, we add a script to it. And there's two ways to script in Godot, either through C# or through GD script. If you want C#, you have to get the C# dedicated version, or if you want GD script, you have to get that dedicated version. Now it's not responding. Why is it not responding? Well, because I pressed the wrong button. This is gonna be the node default, and I've just gotta create it. For you guys, it's obviously going to open it up in this editor, but in my case, wait, what's wrong? Okay, something's going on with Godot. Oh, it's glitching. Okay. Cancel that, create a new script, and create the script. It's generated the C# solution, and it will take us into VS Code. If you want to use VS Code, go into editor settings, .NET, and select this part, and you can set up your code editor of choice. Yeah, VS Code is opening up right now. It's such a pain, isn't it? Yes, I do trust the authors. I am the author. Okay, so this process function, it happens every frame in your game. And this ready function, this only happens the initial frame for the game. Okay, so now what do? We make variables for different things. Oh my god, how many Windows updates? Public integer health. So one of our stats is going to be the health variable. This determines whether the player is alive or not, so it's very important. And then we're going to have a public integer speed variable. I like to use the Pascal case naming convention because it's usually better than other types of naming conventions. What's using Godot? It's not using the thingy? Yeah, what's the problem with it? Well, I found that doing this actually works, but I don't know for what specific reason it does work. Stats. If you put this as a child node of something else, it suddenly starts like working or something. You make a new script for this guy, and then it doesn't work right now. Godot node 3D. The type of, am I missing something? No, I'm not missing anything. It's this thing that's actually not, it's causing a problem right now, guys. Don't worry about it. Okay, the public integer speed will be equal to 10. We want a public integer to represent the damage that each movable target can provide the enemy with. So that's going to be 10. And we want a weight. How fast will it fall down? Public int weight is equal to 10. And the public integer jump force jump force is equal to, I'd say 10. Okay, so every time we want to change a variable, we have to get into the script and we have to do so many changes. We really don't want that. We want to change it in the editor. So we export it to the editor. We say export to export stuff to the editor in Godot. It thinks that this is incorrect, IntelliSense, but IntelliSense right now is just being stupid. So I would like you to ignore IntelliSense ignorance. Okay? This will work, believe me. Oh, what's wrong? Yeah. Export. Export that and export that. Now, these are all the stats of the player. So we can access the health from here, the speed from here, the damage from here, the weight from here, and the jump force from here. I'll show you guys how it works. Now go into Godot and build this. You press this button to build the current scene. So we're building the .NET project right now. See, told you it would work. Now you can adjust health, speed, and these things right from the editor. That's good, right? That's actually a great thing. Now we're going to create another node. This node will store our camera stats. Okay, why do we need the camera stats? We can adjust the sensitivity here. We can adjust the zoom speed here. We can adjust so many things here. So we're going to do the exact same thing we did previously. We're going to make a public integer for, no, it's an integer. Oh, I wrote integer like literally. Public integer sensitivity, which is equal to 100. This is going to be its default value. And the public integer the public vector 3 zoom will be equal to 0, 0, -1. Because in Godot, -1 in the z-axis is forward, like we saw in BlockBench. This doesn't work. Why? Because this is counted as a tuple. Tuple is an immutable data type. We want a vector 3. We want a new vector 3. Yup. Now that will work. So now that we have these two things in camera stats, we can go ahead and export them. And now we press enter and we export this variable too. Such a good thing, right? Now we can save it and we can go back and we can call it camera stats. I'm using title case because I'm used to using title case. It's essentially the thing where you don't give spaces between different things, but you start each new word with capital letters. Okay, now we have the zoom and the sensitivity. That's great, isn't it? So we can either choose to have custom zoom in values. This is the zoom in value. And we can have a zoom out value. We can copy paste this and we can change it to fit our needs, making it zoom out. See, IntelliSense is back on track, no more errors. Now we've got to save this by pressing Ctrl+S and we're building the .NET project now. So zoom out is -1 at default. We don't want that. We want it to be +1 in default. Yup. This execution will change everything. Yeah, so this will be our camera stats and this will be our, what do we call it? Well, just normal stats or movable object stats. Object stats is what we'll call it. So I'm going to save this scene as the object stats. Object stats. I'm going to save it as such and then I'm going to close down the stats scene and I'm going to delete it. Okay, now this will give us a very huge error if we don't save it and close it. Now we have the object stats and the camera stats and now we're going to need one thing more. What is that one thing we need more? Well, it's obviously something to handle the input. And we're going to create a node for that. This node will be our input handler node, or we could call it the position handler node and throw it anywhere. Maybe not. This is going to be the input handler. We want modularity, remember? So now, let me add a script to this input handler. Well, to handle input, we need some input to handle. So we need to create input to handle input. W is forward, S is backward, A is left, D is right. WSAD. And then space is essentially space. And well, we can add D to D. D means right. I think that's pretty intuitive. We can use it for controllers later on, but for now, focus on what we're doing right now. And S and D. No, W. Now we have options to jump, go forward, backward, left, and right. Okay, now let's process the input. But before we do that, we need to add in a zoom in and zoom out action as well. Shouldn't we? We should. We actually should. Okay, so how do we add in a zoom in action? We just add in a zoom in action and a zoom out action. No, I didn't want to call it a zoom out action, so I'm going to trash it and say zoom out. Yeah, for me, I want my arrow keys to control zoom in and zoom out. The up arrow key makes stuff go in, and the down arrow key makes stuff go out. And yep, that's pretty much it. We have all the input that we need to handle input. Now, to actually start creating something, we need to make a new function called public override. No, we're not overriding anything, so it's essentially void. It's not going to return anything, this function. A function is just a set of statements. It can either return something or not return something. It does a specific task when you execute it. It makes like reusability of code better and easier to understand. So we're doing public vector3. The vector3 return type is used here. We're going to return ourselves the velocity, right? It's vector3. We're going to use the input calculator. The input velocitor. What are the values that need to be passed in here? We don't need to pass in any values. That's how it works. Now we're going to check for input, and we're going to make a vector3 variable every physics frame. Vector3 velocity is equal to new vector3. Within parentheses, we make ourselves this word called, what's it? Get access. Input dot get access. Get access. Access. And then we say the negative action, which in our case is A in the x-axis and D in the x-axis. The positive action is D, which is right. I'm not going to take care of the y-axis or the jump right now. We're going to take care of it soon. Input dot get access W is backward, no, W is forward, and S is backward. Why are we doing it in opposite? Take a guess. Yeah, I'm assuming you've taken a guess. In Godot, there's this thing that means that W, when you press W, right, the plane needs to go forward. The negative Z axis is forward in Godot. Sounds very weird, right? It's actually how stuff works in Godot, you know. And now we have the input velocitor. That's pretty much that. Now that we have the input velocitor, we have to calculate the gravity, and to calculate the gravity, we need to do one thing. That is, we need to get the weight. Yep. Now let's go back into stats. And we had weight, right? Let me change that to mass because mass is a more accurate representation of what we're doing right here. Okay. Now I've changed it to mass. We're going to call stats here. And to call stats, you need to do something called putting stuff in a group. And we're going to put this in a group. And the group is going to be called stats. Maybe not. We're going to use object stats. And we've added the group tag. Why are we adding a group tag? Well, it's like saying, hey, object stats, you're in this group called object stats. And since it's the only member here, we can access it by saying object stats each time. Okay? Now, we're going to make a variable of type node. It's going to be called the stats object stats node. Object stats. I'm making variable names very huge because in the future, when we're reading our own code, we need to understand it. So it's object stats is equals get tree. We're getting this thing, like the entire place where we need to search stuff, right? That's the scene tree, and we're getting the tree. And yeah, now once we get the scene tree, we get ourselves the first node in the group, which is the only node in the group, object stats. And by the way, we don't need to worry about typecasting stuff right now. What is typecasting? It's basically changing stuff from one type to another. Since we're getting the first node in the group, we're getting it as a node, and the type of this is a node. Oh no, thunder. Don't mind. Oh my. Is it dangerous that I'm using the computer right now? Okay. I'll continue recording later. Nah, the thing calmed down, so the storm isn't really huge. So I think I can continue recording right now. Okay, the vector3 velocity, we got this right. Now we have the object stats. And the object stats, it has a lot of stuff that's important to us. Like, where did the object stats go? Yeah, the normal stats script. And we have the jump force, health, speed, damage. We can access all of that here. We can say if the input is action just pressed, if the input dot action just pressed is action just pressed jump, or did I call it space? What did I call it? I called it space, didn't I? So I've got to call it space again. And then we can get ourselves the jump force from object stats, and we can say the new velocity right here, it's equal to the jump force. Velocity's y-axis component is equal to the object stats, object stats dot get jump force. I'm pretty sure I called it jump force, didn't I? Object stats, just normal stats, I guess. Yeah, we called it jump force. And it's actually crying because we haven't typecasted it to an integer. Object stats dot get jump force. Yep. Now we can use this as a template to, do other things. And now if the action is just press jump, else if the action is not pressed and we have the player is not on floor. How do we check for player not on floor? Well, first we make a body for the player so that he can inherit himself in the script character body 3D type body. No, name body. Yeah, why did I mess that up? So this is going directly under the player, right? So we can say get parent typecasted it to character body 3D, and then we can say no, there should not be nothing there. Yeah, we're getting the parent as a character body 3D, so remember it should only go under character body 3Ds. Remember that. If the body not body dot is on floor. What's the difference between this and that though? Returns true if the body has collided with floor in the last call of move and slide. Is on floor. Returns true if the body is returns false. The last call of move and slide is on floor. Like collided only with the floor, the last call of only with the floor, So I guess it's essentially is on floor. If the player is on the floor, we check for it. Now we know that the player is on the floor, and so what we will do is we'll get the velocity in the so first let's make ourselves the physics process function. Pretty sure gravity is supposed to be calculated inside the physics process. So with that being said, I'm going to make a physics process here, and let's make a variable called delt. Delt is equals delegate. What the hell? Yeah, I forgot. Public float delt is equal to 0. Yep. Now we can say delt is equal to the float value of delta. No, not delta, it's delta. Okay, so now velocity in the y-axis, we subtract from that constantly object stats. Wait, let me create a new thingy. Let's have a world stats node. World stats node. This is gonna be the world stats node. Okay, so let's call it world stats. These are things that are constant to the whole world. Now world stats.cs, and we're going to export gravity for now. There are many other quantities that are universal, but we're just going to export gravity for now. Public integer gravity with t equals 10 by default. We're going to save this, and from here we're also going to call the object stats node world stats. We're going to put it in a group called world stats. Okay, let me touch this, node groups and world stats. Now I'm gonna save this as world stats. So this will access the world stats and get the gravity for us. How do we get the world stats? Well, that's pretty simple. We just make a reference to it like we made to object stats. We just copy this, paste this, change object to world, and we say world stats. Will you? Yeah. We're going to copy this and we're just going to make a few edits. ctrlv world stats is equal to world stats is equal to get the first node in the group world stats. Yup, we have the world stats node now. Now we can go ahead and get the weight from the object stats. Get the weight. What was it called? It was called weight, wasn't it? No, it was called mass. I changed it. Yeah, it was called mass. So we say get the mass and turn it to an integer. Turn it to an integer. Where did I get it from? Oh no, object stats. Confusion. Oh my god. Multiplied with delt, which is basically the delta value we're setting it to here, and then we're basically multiplying that to our world stats gravity. Integer world stats dot gravity. No, we're not multiplying it with that gravity. We're getting gravity. I forgot that. Gravity. Yup. That's pretty much it. We're nearly done with our stuff. We get this and we multiply this by this. No, this is wrong. I'm going to cut this and this is going to be put into that, and then this is going to be applied. I know this is terribly wrong, but this will let me have a sense of order in my head. Yep, now stuff will work. What do we have to do? Return the value to ourselves. That's all that's left. Return well. Okay, now that we have the velocity, we have to set the velocity to the player's velocity inside the player script. Now AD is for the x-axis. We have the y-axis handle. Let's go. Yeah, now let's actually make ourselves the next thing, which is, well, getting back into the Godot editor and saving the input handler. Input dot, no dots, input handler. This is going to be the input handler. So now we have these things like modularly made so that like we can put them under different things and we don't have to write code for them again. And now let's try making a camera scene. Now we need a camera 3D to make a camera scene, don't we? And we also need something the camera needs to go around. So it's going to be a node 3D. It's going to be a pivot around which it can move. It can rotate around that pivot. And now under the pivot, we're going to add a camera 3D. And under the pivot, we're also going to add the, oh my, the rain. Something just fell down outside. Oh shit, stuff's terrifying. Yeah, we add a camera stats. Yup. Now we just basically say pivot.cs. In camera stats, oh, I forgot to add camera stats to a group. So we need to add camera stats to a group. Camera stats. This is that group that we're adding stuff to. And now underneath the new pivot, we've added camera stats, right? Like first save this and then we can save that and then we can go ahead and save this. We can access our camera stats from this part and look out. Look here. We have the zoom in, sensitivity and the zoom out. Okay, so now let's make this work. Now all we've got to do is make a script for the pivot and make the script. Underneath the pivot, we need camera stats, right? So we're going to say node followed by camera stats. Now we're going to equate camera stats to get node, get child, returns a node by its index. To access a child via its name. We're not accessing stuff via name because that won't be modular enough. So we're going to say, no, we don't need to say get tree. Wait, shit. Oh, what's wrong with this? Okay, so pivot is under camera, so we can't directly access it with name, can we? Are we in the scene tree right now? We are not in the scene tree. So we can say get child count or get groups returns an array listing the groups that this node is a member of. No, Godot class, get class, no, get children, no. No, I don't want the children of this node. Okay, so it seems I can't really do much here with this. We can't put camera stats here. We're supposed to put camera stats inside the scene. Get tree followed by get nodes in group. In the group, camera stats. That's right. Now we have camera stats. What's wrong? Oh, get first node in group. Get the first and only the very first node in the group camera stats. Now we save the script. Now what we've got to do is essentially start coding. The zoom in action and zoom out action, we can start with them. If input.action just pressed is zoom in, put dot action just pressed is action pressed zoom in, then we're going to get the zoom in from the camera stats. Okay, so we need to pay a reference to the camera. So that would be camera 3D. We're making a body for the camera inside our script, which is Cami. I'm gonna call him Cami. Cami, and then semicolon, and then we're going to say Cami would be equal to the scene's current camera. Get viewport followed by parenthesis dot get camera 3D followed by parenthesis, and that is it. Cami dot get camera 3D. No, not get camera 3D. What am I talking? Cami's translation will be equal to the camera stats dot get zoom in. We've got to typecast it to vector 3. So we put a vector 3 before that. Vector 3 dot get. No. Why? What's wrong with this? Camera stats. Yup. Yeah. So now we have the zoom in feature. What about the zoom out feature? So else if the action just pressed is zoom out, just copy this and we paste this here and we edit into out. I could have just copy pasted it again. Yup, this will work. CTRL-C and then I make curly braces and then I paste it here and then zoom out. Yup, that's pretty much it. Zoom in is, let me just check camera stats. Is zoom in supposed to be in? Yeah, it's proper. Everything is proper. Now stuff will work. Now we have the zoom in and out handled. What do we do? Well, the next thing that we're going to do is make our camera rotate around the player. How do we do that? Well, that's a certain way to do it. Let me show you. Okay, so now I'm back. Now let's actually take care of the rotation. We have the zoom in code right here and the zoom out code right here. Now all we've got to do is set up the rotation. How do we do that? Well, just like the physics processes, it seems that there is a different function that can do it. So let's just copy paste public override void there. And let's say underscore. No, it's not enter tree. We're supposed to use underscore input. This base.input event, we really don't need it. All we gotta do is say if at event. That means what event, what is the player inputting, is of the type input event mouse motion, then we can say that copy paste input event mouse motion. That's gone. Oh crap. CTRL-C and CTRL-V. Mouse motion, which is is equal to this within normal parenthesis and at event. We're typecasting that event to an input event mouse motion. And once we've done this, we can actually begin setting the rotation. For this, we need the body of the person. We know that the body is accessed inside the input handler, right? How did we access it? Well, what we did there, we just got a copy paste here. So we take the code from the input handler, then we go back to the pivot, and then we paste it here. It's not really that hard. I'm pretty sure you might have noticed how stuff works around here. So I'm pretty sure you can wrap your head around that too. The pivot is going to be a child node of the character body 3D, so it's going to work as such. Let's put this in the ready. Yep, we're done. Body is equal to get parent character body 3D. So now we are allowed to use the body. Why do we need to rotate the body? Is the huge question in your heads, right? Well, it's pretty simple. I'll explain as I code. Wait, new rotation, new vector 3. Why is it vector 3 twice? IntelliSense sucks, doesn't it? Or maybe I typed it twice. Okay, so now we're going to take care of the y-axis rotation for the player. Why are we doing this? Why do we take care of the y-axis rotation for the player? Well, the actual reason for this is that, well, we want to use the player's transform basis to make sure that whenever the direction the camera is facing is forward. So to make sure of that, we make sure that the body itself is rotating for the y-axis rotation. And for the camera rotation, the camera itself pivots around the pivot. So we need to rotate the pivot. Now, it's 0, the previous rotation, the previous rotation of the body followed by dot x, no, dot y, subtracted from dot relative, which means mouse motion dot relative, which means what position is my mouse relative to this position. This is 0, this is 1, this is 0, this is 1 now, or this is 1 up. It's a vector 2 that denotes how and where it's going. Like, has it moved now? No. Yes. Something like that. Dot relative dot x. And why is it x-axis motion? Well, when we do this, we want the player to rotate like from left to right? So left to right is essentially rotation along the y-axis. So we're subtracting the x-axis motion from the y-axis rotation. That's what we're doing here. And, well, since it's a vector 3, we need to give it one more parameter, which is 0. This seems pretty simple enough, right? Now, let's take care of the actual rotation, which is rotation is equal to new vector 3 followed by the rotation in the x-axis subtracted from motion relative dot y, 0, 0. Okay, now try to understand the logic. When we're doing this motion, we want the camera to go like up, right? We want our camera to go up when we do this, or down when we do this or something. So how much has it gone up, how much has it gone down is a measure of how much we want it to rotate along its x-axis. So we're basically doing that here. And a semicolon to end of the line would work. Yup, our code is done. It's literally done. Yeah, there's literally no catch here. The input handler, we need to modify a bit of that. I'll tell you what we need to modify. We've said that the velocity in the y direction, blah, blah, blah is this, right? Now, what we're going to do is vel dot x is equal to, or asterisk equal to, which means we're multiplying velocity with another variable and we're storing it to velocity. This is called a shorthand operator. This will be multiplied with speed from the object stats. How fast can it go? That speed. So I'm gonna say speed here. And now that we already have done this, we just have to change a word for the next line, which is in the z axis. Yeah, so instead of saying x, we're gonna say z. Oh, CTRL Z. What the hell did I do? Now it's gonna be z. Yeah, velocity in the z is it itself times speed. Once we're done with all of that, we can go ahead backward and we can say that the velocity now is actually multiplied and equal to the transform basis. No, this is not the right way of saying it. So we say velocity is equal to transform dot basis, the body's transform basis, dot transform dot basis multiplied by velocity itself. No, not whelp, it's velocity. Yep, that pretty much sums it up. Now our player will rotate and will move very well. Now that we have all our code set up, why not do a demo, right? Let's start the demo. Okay, we're missing something here. I want you to take a guess at what we're missing. Have you taken a guess? Well, if you're anything like me, you must have thought, didn't we actually define sensitivity inside camera stats? Why haven't we used it anywhere? Well, your question is absolutely right. So what we have to do right now is divide something by sensitivity. What is that something we have to divide? Well, let me show you. The mouse motion relative, right? If this goes to this side, it's -1, or if this goes to this side, it's +1. But in Godot's rotation system, we measure in radians, which means that half a turn is 1 and the other half is 2. So what do we do right now? Seems complex, right? It's not really that hard. Now, thinking really deep about it, all we have to do is divide this by something to make the amount of turns per second smaller. Okay? So to do this, we're going to copy and paste what we got. We can't divide it by a vector 3, obviously. We make it an integer, and then we change this out and swap it out for sensitivity. Not speed, sensitivity. Now that we have this, we can go ahead, take this, copy it, and also divide this by sensitivity. Voila, we're done. Sensitivity is done and working. So now, to make this all actually work, we need to go into the editor and create a new scene. Let's save the pivot. And now, let's make a character body 3D. In Godot, character body 3D, as we all might know, is essentially, how do I say? It's like something you can program physics for. And there's this function called move and slide that's very handy here. We are going to call that function. Okay, so now that we've almost completed everything, what do we do with the script on the character body 3D? That's pretty simple. Let me make it work. Let's call this character body 3D a body, just a test body, you know. Body.cs. Now we should be ready to make it work. What do? Well, all we do is one thing. We're going to make a reference to the input handler function that we're going to throw under it. We've got to throw the input handler under it. What do? We throw the input handler under the body. So now what do? Well, the input handler needs an other friend. And who's going to be that friend? Object stats. And then we're going to need a camera. It's going to be a pivot scene. And this pivot scene needs something else to function as well. Guess what we need? That's right. We're going to need the camera stats scene. Now that we almost have everything, we just need to let the input handler figure out what's going on. But before that, what we've got to do right now is set it up in such a way that this will move. So now, what we're going to do is we're going to get ourselves the velocity of this and set it inside the input handler. But isn't it better if we do it inside the body? That's a question you might ask yourself. So let's do it inside the body itself. Let's start with this line of code. Let's make a space for the camera 3D. No, not the camera 3D. What am I saying? We're going to make a space for the node, that is the input handler node. We have the input handler node now. A space for the input handler node, actually. No, not the input handler, no. Okay, input handler node is equal to get child index. Doesn't really seem correct to me. So to get the scene, what am I supposed to get here? Get tree. No, I'm not supposed to get type, not shape, not real velocity, not property list, not process delta time. What do I need to get? Was it? Okay, for this to be truly modular, we need to get ourselves that node relative to this node, which means I'll have to say get child. But if I say get child, then I'll have to like give it certain parameters. No, this is not gonna work. Okay, let's use get node. This is the most modular option available to us now, and we're going to say get node. We need input handler. We don't need to say any of this. All we gotta say is input handler. And then we put the semicolon at the end. This line basically gets us the node input handler, and since it's the get node function, its default return type is node, and this is also a node, so we don't have to typecast it. Now what we're going to do is essentially make the input handler. Now how do we do that? Well, we have this function called the input handler inside the input handler, right? So let's call the function input handler from the input handler node. No, it's supposed to be velocitor, if I'm not wrong. Input handler, input velocitor, yes. It is called that. So let's copy this for further reference. Let's copy the name of the function, and then let's say call. Call basically tells this function inside that to run, and it gives you the result of that function running. Input handler.call. Well, we remember that it returns us the velocity, right? If you don't remember it, you can see it right under the pivot. No, input handler. It returns the velocity at the end, right? So we need a space to store the velocity. Where do we store the velocity? Inside a space. How do we store the velocity inside the space? That's pretty simple. We basically do only one thing. That is, we say a vector3 called velocity is equal to input handler dot call handler. So what is wrong? Cannot implicitly convert this into a vector3. Yeah, I figured that it would ask us pretty much this. So let's convert it back to a vector3. Now that sums it up for the velocity. Now we need to equate the velocity of this guy to the velocity variable. Seems pretty simple, right? Yeah. Now what we've got to do is essentially call the move and slide function. Move and slide. Yup. We're not really done here, but well, this should actually get us working and in track. Let me set the camera stats differently. -1 is definitely not going to be enough because it's not radians. Let's have -100 and let's have it be 100 here. I think this will work fine enough. Input handler, object stats, pivot. Am I missing something? Well, I am missing something, and that is the body. I'm going to get into BlockBench and export this as a normal. Wait, where's Blocky? Yeah, here's Blocky, the guy we made previously. I'm going to export Blocky as a GLTF model with the model scale export 32. Have a lot of private information inside my documents, so I'm not going to be showing any of that to you guys. Click confirm and then it'll ask you to save it in a name. I'm going to be back after I do that. In 3, 2, and... Okay, so what does the character body need to function? A body, and we're going to give it exactly that. The GLTF that we exported, we've got to pull it back and put it in. That's still the error. But what does this mean? We need a collision shape 3D. That's what it exactly means, Collision shape 3D is going to be what we need. And what the hell has happened to his face, you might think. To fix this, you're gonna have to switch on high quality and re-import all the assets. High quality, re-import, high quality, re-import, high quality, re-import, high quality, and re-import. See, he looks good as new. He's already new, but he's good as new. Yup, we don't really want the camera at his legs, but we also want the camera to pivot around this point, right? So let's go ahead and make some edits to the camera. This is going to be the initial point of the camera, and the preview is going to be something like 1 block above, 2 blocks above. The translation is at, yep, I think that will be good enough. We're gonna have to bend this guy a little bit down and then save it. Yeah, I edited the camera, not the pivot. Thank goodness. Now, this guy seems pretty small, doesn't he? So how do we fix this? We essentially do one single thing. And that is, we're going to have to make this guy bigger. Blocky times 3. He's ultra blocky now. And now, under the collision shape, we add collision shape 3D, and we're going to add a cylinder. No, not a cylinder, a sphere actually. I think this should do. Yeah. CTRL-S. Now that we actually have the sphere and a collision shape 3D, the object must be ready to move. Let's check if we have done everything right. Just once. Yeah. Is anything void or missing? No, nothing is void or missing. So I think we've pretty much completed doing everything here. And hence we're going to save everything. Which means we're going to run the scene right now. Not exactly right now, but in a bit. We're going to make sure to add ourselves a node 3D. Under the node 3D, we want a CSG box 3D. The CSG box 3D is just a box with collisions. Collisions essentially tell you that, oh, I can't bang into this wall. Yep, now I'm actually adjusting the CSG box 3D, and I've added the character, I've saved the scene, and now I'm adjusting the stats just a little bit to get that smooth feel, and it's loading. Okay, so now what are we gonna get? Okay, we got absolutely nothing and a whole bunch of errors. So yeah, that was pretty much the result of what we did. I'm gonna fix these errors in a bit right now. Okay, I might or might have not have tried to resolve that error for half an hour just to realize that I named it a wrong group. I gave it a wrong group. It's supposed to be world stats, right? It's world stats right now. But before this, it was W in small letters. So that's why it didn't work. Now it should definitely work, and it did work based on my last. Okay, so just because something works doesn't mean we have to compulsorily use it. So there's our stats here and everything else. That's pretty modular. I could totally leave it at that today, but I've decided that I want to make the jump feel a lot better. So let's make the jump 5 for now. Wait, and I'm going to show you how I change the jump in a second. See? It feels nice, right? This is how the jump is supposed to feel. As you get closer to the floor, the gravity needs to pull you higher and higher. No, lower and lower. Okay, so the camera, I'll tilt it a bit more downwards, and then I'm going to save it, and then I'm gonna pull the node up to the center, almost to the center. Yeah. See, now it will feel better. This is how the jump will feel in the next thing we're gonna make. Okay, so here's what I did differently. I made this function called jump and gravity here, and I separated the jump and gravity if statements and I put them here. If the action is just pressed is equal to jump, then it basically gets the jump force and it makes it equal to the horizontal velocity. And from the horizontal velocity, we subtract the world stats as gravity and multiply that by delta. And then, since we have a mass parameter here, let's also add in that a mass parameter from our object stats. Object stats dot get mult with mass. Okay, this may feel wrong right now because we haven't typecasted it to IntelliSense. Now that we've typecasted it, we can just write object screw IntelliSense and amazing IntelliSense. It's like it screws itself up and then it fixes it for us. Yeah, the float horizontal velocity variable here, right? It's basically one variable that stores the entire velocity, and it's not in the velocity thingy that we're doing the calculation. We're just doing the horizontal velocity separately, and that is going to make our game better. And once we're here, we call the jump gravity function and it just starts working magically. I hope that you understood that. And the body is on floor. What is this? It activates itself if the body is on floor. And if it's not on floor, then we don't need to do much things. We just need to subtract the gravity. If it's on the floor, we don't have to do anything at all. Boom, we're done. That's literally it. We're done with the horizontal velocity. Now our jumps are gonna look magnificent. So to add a bit of an atmosphere to the game environment, I'm going to add a sun with the color like so. And yep, that's basically a sun. Add sun to the scene. That's gotta make our game look better. Yup, it did make our game look better. Why aren't we jumping high enough? Well, that's because now we have the mass parameter, and the mass parameter basically weighs down our object more. And to fix that, we go to the object stats, and we're gonna go down here, and this is gonna become 4. Okay, so now we're going to go back into the test area, and well, we got a really good jump. It's not really responsive, but I'm going to fix that right now. We just have to meddle with the values right now. We don't really have to do anything at all right now. So let's say that I want this object to have a stat of like 2 so that it will at least be decently heavy. Okay, the jump force is reduced. That's why we can keep this guy at 5 and this at 2. We can now jump. Congratulations, you made a jump mechanic. Yep. That's pretty much it. We're able to actually make stuff that can work right now, and we can go ahead and adjust the stats however we want right in the editor. And guess what? You can put this object stat somewhere else or world stat somewhere else and make an other thing like an enemy input handler and make the AI input stuff for you so that you can have enemies just like that. You don't have to code this again. You don't have to code this again at all. Even for a multiplayer scene, you don't have to code this. Boom, the power of modular programming right in your hands. Go ahead and make great programs. Did that rhyme? No, it did not. Yeah, let me just try this once more. The gravity needs to become more and more as we fall down. That's what's essentially happening here. Because gravity is essentially Earth's acceleration towards itself. We can like change the object stats to make it like jump force is like 10 or something. It's gonna make stuff look a lot more better and natural. See? Feels so good, right? Each jump is so satisfying. In the next video, we'll be doing our level best to animate our character. He can turn now, he can jump around now. All that's left of him is to be animated, and then we can go on to make the enemy AI. Thank you for watching this video. I'll catch you with another one. Bye.